Let's now complete the understanding of binomial distribution with some problems. And the importance of problems after learning a concept cannot be overstated. Problems are very important. Let's now start with problem 4.1. The problem states, find the probability that in tossing a fair coin 3 times, there will be A. 3 heads, B. 2 tails and 1 head, C. at least 1 head, and D. no more than 1 tail. So in this problem, the Bernoulli trial is tossing of a fair coin, and success is defined as getting a head which has the probability half. So we define random variable x, which is the number of heads in 3 tosses. So in this case, n equals to 3, total number of toss. So A is probability of x equals to 3. We will get 3 heads. So we are just simply putting the values in the formula. 3C3, half to the power 3 and half to the power 0. By calculation, we will have 1 by 8. B, probability of getting 2 tails and 1 head. That is simply can be written as Px equals to 1. So again, I am just putting the values in the formula, and you have to do this calculation by your own, and if you do this correctly, you will get 3 by 8. C is probability of at least 1 head. That means we can write it x greater than equals to 1. So that is equals to probability x equals to 1 plus x equals to 2 and x equals to 3. So we have already seen probability x equal to 1 is 3 by 8 and x equals to 3 is 1 by 8, and for probability x equal to 2 we are just using the formula, and by calculation we will get 7 by 8. Now the D is probability of no more than 1 tail. That is same as saying probability of 0 tail or 1 tail. So that means 0 tail means x equals to 3 heads, and 1 tail means 2 heads. So probability x equals to 3 plus probability x equals to 2. So x equals to 3 is 1 by 8, and probability of x equals to 2 is again just using the formula, we will get half. Now let's continue with problem 4.2, which states in 5 tosses of a fair die, 3 will appear, A twice, B at most once, C at least twice, and we have to find the probability of each of these cases. So here the Bernoulli trial is tossing of a fair die, and success is defined as appearance of 3. So what is the probability of success? We all know 1 by 6. So now x, so just note that x is the random variable which denotes the number of success in 5 trials. So what is the probability x equals to 2? This is very simple. Just put the values in the formula. 5C2 half to the power 1 by 6 to the power 2 and 5 by 6 to the power 3. Upon calculation, you will get 6 to 5 by 3 triple. Just do these calculations by yourself. B is at most once probability that x equals to 0 or x equals to 1. So this is same as probability of x equals to 0 plus probability of x equals to 1. And again we are just using the formula 5C0, 1 by 6 to the power 0, 5 by 6 to the power 5 plus 5C1, 1 by 6 to the power 1 and 5 by 6 to the power 4. So do this calculation again by yourself and you will get 3125 by 3 Now the last question is probability of x is at least twice. That is, x is equals to 2 or 3 or 4 or 5. There are total 5 tosses. So probability of x equals to 2 plus probability of x equals to 3, and like that up to probability of x equals to 5. So we'll do this calculation again. I am just skipping the details of the calculation. You will have to do it yourself and just check the final answer, which is 763 by 388. Now let's move on to the third question, 4.3, which is find the probability that in a family of 4 children there will be at least one boy, B at least one boy and at least one girl. So again the same steps should be followed. Identify the Bernoulli trial here. Bernoulli trial is birth of a child. And if you see the problem here, there are total 4 children, so n is 4, and probability of boy is equals to probability of girl is equals to half. So we are defining the random variable x, which is the number of boys in 4 trials. So for at least one boy, we will find probability at least one boy equals to probability x equals to 1 or 2 or 3 or 4. This is, we will just write it in the same way as the earlier problems. So we will do this in an alternate way. So I will show you the alternate method now. So probability of at least one boy is equals to 1 minus probability of no boy. Probability of no boy in the family of 4 children. So 1 minus p x equals to 0. So 1 minus p x equals to 0, we will just use the formula 4c0 half to the power 0 and half to the power 4, which will be 1 minus 1 by 16 or 15 by 16. So this is the answer of part A. Now for part B, probability of at least one boy and at least one girl. And this can be written in the following way. This is 1 minus probability of, so I will ask you to pause at this point and think about it yourself and make sure that you find the reasoning behind writing this line before moving on to the next problem. So this is same as 1 minus probability of no boy or probability of no girl. So probability of no boy or no girl means there is a plus sign in between. So now we will go forward. So we will just write the formulas now. 1 minus probability x equals to 0, no boy, and probability of x equals to 4, which is same as probability of no girl. So we will just putting the formula in. This is same again and again before. So I hope that there would not be any problem in this calculation. So the answer is 7 by 8. Now the next problem, problem 4.4, which is out of 2000 families with 4 children each, how many would you expect to have A at least one boy, B 2 boys, C 1 or 2 girls, and D no girls. So this problem 4.4 is closely linked with the earlier problem 4.3, and refer to that problem if you don't understand. So in the earlier problem we have calculated the probability in a family of 4 children. We have calculated the probability how many were boys. And we have seen in problem 4.3a that in a family of 4 children, probability that there is at least one boy is 15 by 16. So we have calculated this in the earlier problem 4.3a. Please refer to that. So in this problem, how many families will have at least one boy? There are 2000 total families. So 2000 into 15 by 16, that will be 1875. Then the second part of the problem, B, how many families will have 2 boys? That is 2000 into probability of 2 boys in a family of 4, which is 2000 into 4C2 half to the power 2 into half to the power 2. So upon calculation it will be 2000 into 4 into 3 by 2 into half to the power 4 is 1 by 16, and this is 125, sorry 250, and this is 750. The answer B is 750. C is probability 1 or 2 girls. So 2000 into probability 1 girl or 2 girl, that is 2000 into probability of x equals to 3, or the probability of 3 boys and probability of 2 boys. So 2000 into 4C3 half to the power 3 and half plus 4C2 into half to the power 2 into half to the power 2. So again, make sure that you do this calculation by yourself and check the answer here, which will be 1250. And the last probability of no girls, that is 2000 into P of no girls, that is same as 2000 into probability of 4 boys, which is 2000 into 4C4 into half to the power 4 into half to the power 0, which will be 125. Okay. Now the next problem 4.5. So it is said that 20% of boards produced in a machine are defective. So out of 4 boards chosen at random, what is the probability that A 1, B 0 and C less than 2 are defective? The process is same. Find out the Bernoulli trial first, which is choosing a bolt, and the probability of that bolt being defective is 20% or 0.2, and this is the P. And in this problem 4 bolts are chosen, so we have n equals to 4. So x, the random variable, is the number of defective bolts when we choose 4 bolts at random. So A, probability of x equals to 1, that is there is only one faulty bolt. The probability of that is 4C1, 0.2 to the power 1 and 0.8 to the power 3. And upon calculation it will be 0.4096. B is 0 bolts are defective. That is probability x equals to 0. Is equals to 4C0, 0.2 to the power 0 and 0.8 to the power 4. And after calculation we again get the same result. 0.4096. Now the last one is probability less than 2 are defective. So x is less than 2. So probability of x equals to 0 plus probability of x equals to 1. And just adding the previous two results, we will get 0.819. Now the problem 4.6, which is find the probability of getting a total of 7 at least once in 3 tosses of a pair die. Here the Bernoulli trial is tossing of a pair of fair die, which is tossing 2 fair dice, and success is defined as getting a total of 7. So probability of getting a total of 7, how do you find this? So 7 can be obtained by 1 and 6, 2 and 5, 3 and 4, 4 and 3, similarly 5 by 5 and 2, and 6 and 1. So there are 6 ways by which 7 can be obtained, and there are total 36 of possibilities. So the probability of getting a total of 7 is 1 by 6. So now the dices are tossed 3 times, so n equals to 3, and x is the random variable, this number of times. The sum is 7. So we have to find probability x is at least once. So probability x equals to at least once means 1 minus probability of x equals to 0. So 1 minus 3 is 0, half to the power 0, and 5 by 6 to the power 3. So after calculation, we will arrive at the value 1 minus 125 by 216, which is 91 by 216. Let's move on to the next problem. Problem 4.7. Find the moment generating function of a binomial distribution. So I have earlier in previous video, I have stated the formula for this, formula for moment generating function. Now basically we will prove it. So x is the binomial distribution with parameters n and p, and moment generating function can be written as mxt, which is expectation of e to the power tx. So mxt is expectation of e to the power tx, means summation e to the power t small x into fx for x 0, 1, 2 dot up to n. So this is same as e to the power tx, and we are writing fx for a binomial distribution, which is ncx p to the power x and q to the power n minus x, where q is 1 minus p. So this can be written as we will take the ncx in the beginning, e to the power t whole to the power x and q to the power n minus x. This is same as p to the power t plus q whole to the power n. So if you don't understand this last line, just look at this formula, refer to this formula, a plus b whole to the power n. This is a to the power n plus nc1 a n minus 1 into b plus nc2 a n minus 2 into b square plus dot 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 for the rth term ncr a to the power n minus r into b to the power r plus at the end b to the power n. So this is same as summation of ncx a to the power x, b to the power n minus x for x equals to 0, 1, 2 up to n. Now just put p to the power t in place of a and q in place of b in this formula of a plus b whole to the power n. And if you do this, you will get the above result. Let's continue to the problem 4.8, which is x is a random variable following binomial distributions with parameter n and p. Find mean and variance of x. Let's start with mean. So let us assume that there are n Bernoulli trials denoted as x1, x2 up to xn, and for each of these trials let's define the value of xj is 0 if jth trial is a failure, and the value is 1 if the jth trial is a success. So now if you define x is the sum of all these Bernoulli trials x1 up to xn, then capital X follows binomial NP. This is just the definition of binomial distribution. So there should not be any confusion. If you have any confusion, just pause for a moment and read it again. So now expectation of x is expectation of x1 plus expectation of x2, like that. This is just the property of expectation, and there are all of them are p. So there are total n number of p's, and the value is np. So expectation of x is np, which is the mean. The formula for mean and variance of a binomial distribution is given in a previous video. So these are just the proofs. Now the variance. So variance of xj is expectation of xj minus p whole square. Here note that xj is the individual Bernoulli distribution and p is the probability of success, or p is the mean of each individual binomial distribution. So xj can have two values, 0 and 1. 1 means success with probability p, and 0 means failure with probability q. So expectation of xj minus p whole square equals to 0 minus p square into the probability of that q plus 1 minus p square into the probability p. So we are just simplifying this. Make sure that you understand how the mean of each Bernoulli trial becomes p. So that is a very important thing. Just refer back to the very definition of expectation of x, which is also mean, and find it out in your own comfort. So upon simplification, we will get PQ. So this is the variance of one individual Bernoulli trial. So x is x1 plus up to xn. So the variance of x is variance of individual sum of variance of individual Bernoulli trials, and there are total n elements, so npq. Again, I will reiterate, the mean and variance of a binomial distribution should be remembered as a formula, and the previous problem just shows the proofs. Now the problem 4.9, if the probability of a defective bolt is 0.1, find the mean, the standard deviation of the number of defective bolts in a total of 400 bolts. So the Bernoulli trial is picking a random bolt and which has the probability of success, which is defined as the bolt is defective. So the probability of that is 0.1. Okay, and there are 400 bolts, so n is 400. So the mean is np. This is from the formula, that is 400 into 0.1 is 40, and the standard deviation is root over of variance, which is root over of npq, which is 400 into 0.1 into 0.9, and upon calculation we get root over 36 or 6.